Hello everyone, welcome back. We're up to 3.4, polynomials and expressions. So, quick little recap, what is a term? Today, this lesson was meant to be more of a note, so it was going to be put up on the board for you guys to copy out, so get a copy in. What is a term in math? We reviewed this last class a little bit. It is a combination of letters, numbers, and the exponents. The exponent is important. Identify the parts of the term. So the number, oh, not right, there we go. Actually, let's not do that. Number equals coefficients. Horrible at writing. X equals variable. And 3 is the exponents. Now, the next, a good chunk of high school, you're going to be looking at polynomials. And thinking like polygons, when we were talking about shapes, triangles, squares, circles, all that sort of stuff, we're looking at how many sides something had with a polygon. Polynomial is telling us how many terms there are. Now, we actually use the same terms that they used in for shapes. So there was no such thing as a monomial because you couldn't have a one-sided shape, or a binomial, two-sided shape, but you're probably familiar with those things from other things. A monorail is called that because it has one rail. A bicycle is called that because it has two tires. And here you can see we have in a monomial that we only have the one term. In a binomial, we have two different terms. Notice, even though both of them have numbers, both of them have the same variable, x, because they have different exponents, they are different terms. Handwriting really isn't getting better. Trinomial means there's three terms. Now for us, we're going to be dealing with binomials quite a bit. Now it won't be x squared and x. For us, it's going to be x and a number. Now, a polynomial technically is anything that has more than one term because poly means more than one. But usually when we name a monomial, we name a binomial, we name a trinomial, and then anything bigger than that is a polynomial. Now, there's something called degrees of a polynomial. And polynomials get classified by the total number of exponents. And that's not really the total exponents that are in a polynomial. It's the biggest degree of all the terms. I think I've said it before that math is racist. I've also said, well, here I'm adding in that math might makes right. The biggest degree wins. So, for example, here we have an exponent x squared. There's only one exponent. The exponent is 2, so it's degree 2. In this trinomial, we have x squared, we have x to the power of 1, and then we have no exponent at all. The largest exponent is the x squared, so this is considered a degree 2 equation. In this one, we don't include the numbers. We do look at the variables though. So here we have a squared, I'm sorry, and then it's b to the 1. So the combination of the two is degree 3. Again, we ignore the numbers, but if we look at this one, 2 and 4 means we have a 6 here, come on, and here we have a 7. So 7 is bigger than 6. This is a degree 7 equation. So have a look at the following terms and see if you can't figure out what the degrees are. Oh, and name the type of polynomial. Okay. Now it's a degree 6 because if you look at that first one, x and z, 4 and 2, they combine to give you a 6, which is bigger than 5. Now, C was a bit of a trick question. It is a binomial. That part hopefully was straightforward. But in order to figure out your degree, you got to simplify this a little bit, right? Because if you notice, we have w to the 7 divided by w squared. And the second one, we have exponents. So this is a degree 10 equation because once you expand everything out, you get a slightly different picture than it looks like, right? Because here, the W7x of the 4 looks like it should be degree 11. But once you factor in that division, it changes things around. We're going to get into, we're going to end up using algebra to describe a lot of real life situations. People always ask, what's the point of all this stuff? And at the end of the day, math is meant to help solve real life problems. Now, a lot of the real life problems that you guys will deal with is a lot easier than what we present here, but algebra allows us to solve some really complex stuff down the line. You guys are learning to crawl. So Jordan works as a ski instructor. He earns $150 per season, $25 for children's lessons, $35 for adults lessons. Write an expression that describes Jordan's earnings. He gets paid $150 per season. So he gets that no matter what, and it doesn't change. He gets $25 per children's lesson, and he gets $35 per adult lesson. Now, E equals earnings in dollars. C is children's lessons. And A, adult lessons. Or lessons for adults, I suppose. So Jordan gives lessons for 8 children and 6 adults. How much does he earn? Now, one of the common mistakes I find people do is that they always want to piecemeal this and do their own thing and figure it out the way they would back in grade 7 and 8. What really happens, what we want you to start doing is you've made a formula, use the formula you made. Okay? Because again, the formulas get more complex, but the better you get with formulas, the more it allows you to do. And there's some stuff that eventually you just get to the point you can't do it in your head anymore. So, and the nice part about my letters, C is for children. A is for adults. Oh, it doesn't. What the heck am I doing here? Copying out the wrong stuff. Uh, 35, 70, divided by 2. Yeah, 210. There we go. Now, it's a word question, so it deserves a word answer. Therefore, blah, because I'm just too lazy to write it out. And that's all she wrote for today.